Guys, I wanted to send you just a few more work through examples from the homework because I know that I get questions on these every time, and I also know we were limited on time last time. So what I want to look at are a couple of, I guess, few word problems here, but situations where we could actually use quadratic functions to our benefit in order to, say, find like a maximum or a minimum product of things. So number 29 here is a perfect example of what I mean. It's really kind of a procedure that I want to take you through. The process is going to be the easy part, or the procedure is going to be long, but the actual answer is going to be the easy part here. So we say among all pairs of numbers whose sum is 20, so no matter what numbers you choose, as long as they add up to 20, I want you to find the two numbers that actually have the largest product as possible. So when we say product, this means multiply together. And so what I want to start with is this. Because we're looking for two numbers, among all pairs of numbers, find a pair of numbers. What we're going to do is we're going to start by defining our variables. And so we're going to say let x equal our first number, and we're going to let y equal our second number. Now the way this works is I want to set up the relationship that was explained to me from this problem, and what was explained to me is that this is two sets of numbers here, or it's a set of numbers whose sum is 20. So we're going to say that, hey, here's what I know about these two things. X plus y is actually equal to 20. What I want to do is find these two numbers that would actually cause their product to be as large as possible. So we know that their sum is 20, and what we want to do is we want to write the product of these two numbers, which is really easy to write. We would say that this right here, we want it to be as big as possible. So what would these numbers have to be? So what we're going to do is we're going to say, well, our first number, x, it's already x here, and I'm going to leave this as an x. But what we want, okay, is to rewrite x or y in terms of the other, variable. And so what I mean is that I really want to write the product of these two things, but I don't want it to be an x and a y. I'd rather have it just be an x and then something in terms of x, or I'd rather have it be a y and something in terms of y. So what I mean by this is, once you set up your initial relationship and you say, here's their product, then what we're going to do is we're going to take, say, for instance here, y, and I'm going to get y by itself here in terms of x. That is to say, I'm going to subtract x over to this side so that I get the same statement but written this way. And the reason why I would want to do this here, we would say that our second number, okay, y, another way to write y is that it's really 20 minus x here, okay, is our second number. Basically, instead of writing y over here, now I can write this. I could say the product of these two numbers is not x times y, but it's really x times 20 minus x. Now, here's the fantastic thing about this. We would say this is quadratic. Now, I know you don't believe me, so here's what I'm going to do. I'm going to multiply this out, and I'm going to clean it up a little bit here, but we have a product, and we get 20x minus x squared. I really do want to write this in standard form where our exponents are in decreasing order here, but what I want you to see is that let me fix that, so 20x. But what I want you to see is that we get a second degree quadratic thing here, and it has a negative a value. So really, hate to throw this at you, but it's something you kind of probably already know. It's a downward opening parabola. And what we want to do is find where this product would be a maximum. What I want you to understand is that this product here, it's kind of like taking the place of what we usually have as an f of x or a y value. And I'm not going to confuse y with this y over here. I'm just using y to represent the second number. But here, I'm saying basically what we want to do is find the maximum product. Well, what we're going to do is we're going to find the x value at our vertex, and then we're going to find the y value at our vertex here. This is going to represent the max product, okay? And in this case, x is going to represent, well, our first number, and we're going to use that to find the second number. But here's what I want to do. Find the vertex of this. So if all I'm asking us to do is find the vertex, well, I guess all I need to do is find a, b, and c here because it's in standard form, and we'll go find the vertex like we know how. So we would say that, well, here's my quadratic thing here. I suppose I'm going to write these down. My a value is -1, my b value is 20, and why not? Our c value is 0. But basically we would say that the axis of symmetry, if this is a parabola that's being graphed, would be at -b over 2a. And so I would plug these numbers in here. As a matter of fact, our b value being 20 and our a value being -1, I put these in. What I get is a -20 over a -2, which comes out to be 10. So I'm going to put a box around this. Now, what we just discovered was the x value at our vertex. And so to put this into context, what we really just discovered was what our first number should be. So we would say that the vertex of this parabola is at 10, comma, f of 10. Now what we'd want to do is go find this because it's going to represent our maximum value. So how would I find f of 10? Well, I would plug this back into our product equation here where we've got it all in terms of x. But I would see that just using a calculator even, here's my function right here, negative x squared plus 20x. I can type in negative, in parentheses, 10 squared plus 20 times x, which is 10. I get this right here. I basically get 100. Okay, so we say 100 is our y value. So to answer this question here, the interesting thing was we found that the x value, or what x would have to equal in order to produce this maximum product of 100 is 10. And by the way, if x is equal to 10, that's our first number here, answer that question, then our second number would be 20 minus x, or in other words 20 minus 10, which gives us another 10. So the two numbers that add up to 20 that give us the maximum possible product of those two numbers would be 10 times 10. So we do want to answer this question here, and because my handwriting is just absolutely rubbish, what I'm going to type is the pair of numbers is 10 and yields a max product of 100. Okay, so you know, I want to try this again here, and I want to kind of try to use the same procedure because it's something I want to know how to do. But, you know, there are steps that we're going to take in each one of these. So, for instance, number 30 here. Among all pairs of numbers whose difference is 16, find a pair whose product is as small as possible, and what is that minimum product? So what are the numbers, and what is the minimum product that they produce here? So again, here's what we're going to start with. We say, well, we're looking for a pair of numbers. Let's define our variables here. So how about I use different letters this time, just to show you it wouldn't matter here. Let's let A equal the first number. We want to define this, and B equal the second number. So what we were told about these two numbers is that if I'm going to find their difference, that is like A minus B, I know that it comes out to be 16. And what I want to do is say, well, I want to find which pair of A and B here that subtract out to be 16 give us the smallest possible product. So we're going to write the product over here as well. And the product is just, well, you know, x times y. Sorry, I forgot we're using different letters here. We just say A times B is their product. So in order to do this, we're going to do the same thing. We're going to write this product quadratically, but in order to do that, we have to rewrite A or B in terms of the other one. So I like to make these both in terms of A. So what I'm going to do is I'm going to isolate B over here. As a matter of fact, I've just changed my mind. I notice here that it's a lot easier to get A by itself. So I'm going to add B to both sides. And what I learn is this. I know that A is actually equal to 16 plus B right here. So over here where we see an A, we're going to rewrite this. We're going to say our product then is instead 16 plus B times B. Or after we distribute here, okay, we get our quadratic function. We get 16B plus B squared. And because I want this to be in standard form, then we would say that this is B squared plus 16B. Now I hope you notice that our leading coefficient here is a 1, and so this is actually an upward opening parabola, but also notice that we're trying to find the product that is as small as possible. In other words, we're trying to find the minimum, and a min or a max always occurs at the vertex. So if what we want to do is find vertex values here, let's do this. We're going to find our axis of symmetry value first, which would be negative B over 2A if it's in standard form. So our B value is 16 here. Our A value is a 1. We actually get negative 16 over a positive 2. We get negative 8. And so with respect to our vertex here, we would say that our A value, or x value in this case, would be negative 8. What we need to go do is find f of negative 8. And so again, grabbing our calculators here, we do have a function here. It'd be b squared plus 16b. We're going to type in b, which in this case is negative 8. We're going to find that squared, okay? And we're going to say plus 16 times negative 8. What we end up with is negative 64 here. So what we want to do now is interpret our results. What are we finding out? Well, first of all, we found out that x here, and I hate to say that I used x, we should have used, I guess, b was our input, but basically our second number here, or b, that would have to be a negative 8. And by the way, if it is a negative 8, then our minimum product would be a negative 64. So to answer the rest of our question, we would say, well, okay, well, if b is negative 8, what's our a value here? Well, all we have to do is go plug this back in right here, and what we get is A equals 16 plus a negative 8, which in other words gives us an 8. And so again, to give a solution here, typed out in words, we would say the pair of numbers is positive 8 and negative 8 and has a min product, oh my goodness, of negative 64. I wrote on top of that stuff, you guys. I hope you can handle that, because I don't even know if I can handle it. So let's take a look at this last one here. What we've got is this fence right here, and because we were working with quadratic things, what I'm going to tell you is squared things. We're going to be talking about squared feet, or in this case, we're going to be talking about area. So whenever we involve area problems, we tend to see some things where we can involve quadratic stuff. So it says that we have 600 feet of fencing to enclose this rectangular plot that borders on a river. It says if we do not fence this side that is along the river here, then what I want to do is I want to find the length and the width of the plot that will maximize the area, okay? And what is the largest area that can be enclosed? So first things first, we want to find the length and the width here. And the neat thing about it is that I suppose I'm going to call the length this right here 600 minus 2x. So I'm going to say if the width is x, okay? What they're telling us is, well, all the way around we have 600 feet to work with here. And so if we were to have two of these x's right here, be this right here, then this side right here would be the total amount, 600, minus these two sides, or two of these x's, that would leave behind this side. So the nice thing about this one is we already have both of our width and our length in terms of x, or in terms of the same variable here. So if what we want to do is find the length and the width, okay, of the plot that will maximize area and find the largest possible area that can be enclosed, let's just start with this. We say that area is length times width. We want to be familiar with this formula because really what we're going to say is we've got area is our length, which in this case we say is 600 minus 2x, times our width, which is just x. So I hope you can see that after this, after distributing here, what we end up with is something that's definitely quadratic, so we get negative 2x squared plus 600x. Furthermore, I would see that because my a value is negative, we would have some downward opening parabola wherever it's at. But what we wanted to do was find two things here. We want to find the x value at our vertex, which would tell us the width here, and which in turn would tell us the length, okay? But we would also want to find what is the maximum area value that we would get here, or maximum y value, which in this case represents the area value. So just like we normally do, let's go ahead and find our axis of symmetry equation here. We would have negative b over 2 times a. So we get negative 600 over 2 times negative 2. I actually get a negative 600 over a negative 4, which in turn gives us here, I'm going to have to find some room. Sorry guys. Negative 600 over negative 4 is the same as positive 600 over 4. I believe we get 150. So what we find out is this. 150 is our x value at the maximum. At the maximum area, our x value would have to be 150. So to answer this question already, I'll even put it in red, you guys. We already know then the width would have to be 150, and I'm a big advocate for put on the picture. So to find the maximum area, as we normally do, we would say, well, if my vertex is at 150, then my y value is at f of 150 here. So again, grabbing our calculator, we're just going to take our x value at our vertex and go put it into this function right here. We would get negative 2, 150, and parenthesis squared, plus 600 times in parentheses 150. Okay, so we would get 45,000 is our vertex value here. So we get 45, and I'm not going to put a comma on that one there. But what we found out was essentially this. We found out, first of all, the width will have to be 150 feet. Now, what would the length be if we know that the width at our maximum area would have to be 150 feet? Well, it would be the 600 minus 2 times 150. In other words, if this is 150 plus 150 and that adds up to 300, then this is 600 minus 300. So we would say the length, 300 feet. And it will produce a max area of 45,000 feet. So with all of these, we're going to set up basically a product of two things. You notice if it's area or if it's a product of two numbers, and rewrite one in terms of the other. But once we do that, we end up with some quadratic function that we can always find vertex values at in order to answer the question we've been set out to find. Cheers.